Hey guys, how you're doing? In today's video we are going to talk about the L'Hopital's rule, which is a rule that allows us to compute certain limits of indeterminate form. What does exactly says that when we want to compute the limit as x goes to some values a, which can also be infinity, of f of x over g of x, and this is equal to or infinity over infinity or 0 over 0, so is in a indeterminate form, then the limit as x goes to a of f of x over g of x is equal to the limit as x goes to a of f prime of x divided by g prime of x. In today's video we are going to see how to apply this formula, all the situations where this can be useful, and where it's actually better to avoid using it and use another technique. So grab your pen and paper and I will see you in a minute. As a first example of application of the L'Hopital's rule, I want to compute the limit as x goes to 1 of the log of x over x minus 1. So, as usual, we just plug into the value for x at the very beginning, and what do we get? We get the log of 1 is 0, and 1 minus 1 is 0, so we get the form 0 over 0. Let's look at the general L'Hopital's rules, where it tells us that if the limit for x going to a, and our a in this case is going to be 1, of f of x, which in our case is the log of x, over g of x, which in our case is x minus 1, is equal to 0 over 0, then this limit is actually going to be equal to the limit of f prime over g prime, and x is always going to a. Well, let's apply this rule. So this one is going to be equal to the limit as x goes to 1 of the derivative of the logarithm is 1 over x. So we have 1 over x divided by x minus 1, the derivative is just 1, which means that we have 1 over x, for x going to 1 is equal to 1, we have 1 over 1, which is 1. And this means that after applying the L'Hopital's rule, we get that the limit as x goes to 1 of x, of the log of x divided by x minus 1, is just going to be equal to 1. As a second application of the L'Hopital's rule, we are going to compute the limit as x goes to infinity of e to the x divided by the log of x. So, when x goes to infinity, e to the x goes to infinity, and the log of x as x goes to infinity too. And exactly both of them go to plus infinity. Well, okay, great. Again, we are exactly in the L'Hopital's rule setting, but in this case, the function f of x will be e to the x, and the function g of x will be the log of x. So what do we have to do? Well, this is equal to the limit as x goes to plus infinity of the derivative of e to the x is e to the x, divided by the derivative of the log of x is 1 over x. And now, as x goes to infinity, what do we get? We get e to the x goes to plus infinity, and 1 over x, as x goes to infinity, goes to 0. In particular, it's going to be a positive number, because 1 over a number is getting bigger and bigger and bigger is going to be positive. So we're going to be 0 plus. Which means that we have plus infinity divided by 0 plus, and this is going to be just plus infinity. And again, as before, we have just applied the L'Hopital rules once, and we found a limit that we can actually compute immediately. As a third example, we are going to compute the limit as x goes to 0 plus of x log of x. As before, just plug the value x equal to 0 inside your limit, and what do you get? You get 0 times the log of 0 is minus infinity. So we get an indeterminate form, 0 times infinity. But this indeterminate form is not one of the two for which we can apply the L'Hopital's rule. Indeed, it's not of the form infinity over infinity or of the form 0 over 0. So how can we solve this situation? Well, we have to massage a little bit the function in the following way. I'm just going to rewrite this limit as the limit as x goes to 0 plus of the log of x divided by 1 over x. Nothing changed, okay, the function is exactly the same, but now when I plug into the value x equal to 0, I do get the log of 0, which is minus infinity again, divided by 1 over x, as x going to 0 plus is going to plus infinity. So again, now I'm in a situation where I have the limit of the quotient of the function, and this quotient is the form infinity over infinity, which is one of the L'Hopital's rule hypothesis. So now I can apply the L'Hopital's rules here, and I can rewrite this limit as the limit as x going to 0 plus. Now what the derivative of the log is 1 over x, and the derivative of 1 over x is minus 1 over x squared. Let's flip it. So this one is going to be the limit as x going to 0 plus of minus, because we have a minus over there. When we flip to 1 over x squared, we get x squared divided by x. So this one is just going to be equal to the limit as x goes to 0 plus of minus x, and this is going to be equal just to 0. So now we know that the limit as x going to 0 plus of x ln n of x is equal to 0. And what we have to do is just recognize that this form can be actually written in a way where we can actually apply the L'Hopital's rule. As a last example for today's video, I want to show you a situation where it's actually better to not use the L'Hopital rule, even if we can use it in principle, but it will lead to a lot of calculation and we can actually avoid all of them if we are a bit careful. So I want to compute the limit as x goes to plus infinity of x to the power 7 plus x to the power 5 plus x to the power 3 divided by x to the power 4 plus 2. Let's just plug x equal to infinity in our limit. In the numerator we get infinity, 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 so this is plus infinity divided by plus infinity. Okay. So in principle now we are able to use the L'Hopital's rule, okay, because we are in a situation with f over g and the limit is infinity over infinity. But if we try to apply it, well, we get that this guy is equal to the limit as x goes to plus infinity of 7x to the power 6 plus 5x to the power 4 plus 3x to the power 2 divided by 4x to the power 3 plus 0. And again, when I plug into plus infinity, I get plus infinity over plus infinity, which means that in principle I have to reapply again the L'Hopital's rule, so I have to take another derivative, and this might happen over and over again. So to avoid this situation of getting in this loop of the L'Hopital's rule, we can actually try to leverage the fact that we are dealing with a quotient of two polynomials. What's the idea in this case? Whenever you see that you have a quotient of polynomials, so as in this case, and you're considering the limit as x goes to plus or minus infinity, what you have to do is collect the bigger order in both the numerator and the denominator in the following way. So this one is just the limit as x goes to plus infinity of what? Of x to the power 7 times 1 plus x to the minus 2 plus x to the minus 4 divided by x to the power 4 times 1 plus 2 times x to the minus 4. And why I'm doing this? Well, because now I can simplify the x's right in front here. So what I get that this 7 becomes a 3, and this one simplifies out. And now, when I try to plug plus infinity there, what do I get? I get x to the power 3, when x goes to infinity, goes to plus infinity, times 1. And now x to the minus 2 is equal to 1 over x squared, which as x goes to plus infinity goes to 0. Same things apply for x to the minus 4. Indeed, this is just equal to 1 over x to the power 4. And when x goes to plus infinity, 1 over x to the power 4 goes to 0. So in the numerator, I get 1 plus 0 plus 0 divided by x to the power 4 is gone. So 1 plus 2 times x to the minus 4 is still going to be 0. So at the end, infinity times 1 is infinity. So I get infinity over 1, which is plus infinity. Okay? So I was able to compute this limit without using the L'Hopital's rule. So I didn't have to compute any derivatives. And in just one step, I was able to solve it. So in case if you are in a situation like this, try to do this collection. Okay? Just collect the higher order degree in both the numerator and the denominator, and you're gonna be good. So guys, that's all I have for you for today. I'll see you next time.